So paramagnetic property and diamagnetic property. So we have lots of types according to the first lesson what we did. It's a ferrous, ferric magnet. So but as per the notification of the coordination compound, we have only two types of coordination compound, that is magnetic properties. One is paramagnetic and second one is diamagnetic. So paramagnetic means the atom, the outer electronic configuration, that is valence orbital, having at least one unpaired electron. So the charge, the paramagnetic means to say the outermost valence electron should contain at least one unpaired electron. That is called paramagnet. So paramagnet anta ಹೇಳಿದ್ರೆ at least ಒಂದು unpaired electronಗಳು ಅದರಲ್ಲಿ ಇರಬೇಕು. ಅದನ್ನ ನಾವು paramagnet ಅಂತ ಕರಿತೀವಿ. Okay. So what do you mean by diamagnet? Diamagnet means to say that it doesn't having any single unpaired electron. Single electron. So outermost electronic configuration ಈ ತರ ಒಂದು electron ಇದ್ರೆ ಅದನ್ನ paramagnet ಅಂತ ಕರೀತಾರೆ. If in case pair electron ಇದ್ರೆ ಅದನ್ನ diamagnet ಅಂತ ಕರೀತಾರೆ. Okay. So if it is single electron, that is paramagnet. If it is pair electron, that is two electron, that is called diamagnet. Okay. So let us write the example for it. It's of titanium plus 3, vanadium plus 3, chromium plus 3. Write the electronic configuration, outer electronic configuration for all this. Titanium plus 3, vanadium plus 3, chromium plus 3. You can give lots of examples: manganese, copper, cobalt, ferrous. Okay, write down the electronic configuration for these three and check it out whether it will comes for the paramagnet or diamagnet. Write down the electronic configuration for this first. Srujan, Mohammed. Meghna, Gokul. The limitations of VBT theory. Limitations of VBT theory. So we propose the Vibhuti theory, that does that Vibhuti theory is accepted, or if it may have some what to say, drawbacks. So if drawbacks is there, let us see what are those. So first is, almost all postulates what they have written is assumed postulates. So while explaining, they are saying there may be, it may be like this or it may be like that. The outermost electronic configuration or the valence orbital are going to pair. It doesn't having any ethical or and calculatical or theoretical proof to explain that the postulates. ಅವನು ಏನ್ postulates ಹೇಳ್ತಾನೆ, ಆ postulates ನ prove ಮಾಡಕ್ಕೆ ಅವನ ಹತ್ರ theoretical proof ಇರಲ್ಲ. He don't have an theoretical proof. Okay, so that is why it's called as most of the theories and postulates are assumed one, and is not giving quantitative interpretation of magnetic data. He is not giving any terms or explanation regards the magnetic property or the, so as of we know that electric field is there, then it surrounds by the magnetic field. However, so but he is saying about that there will be a charge developed, there will be a movement of the particles anteella heltaralva, movement of this there, and you can see the bond and non-bond pair electron. So but he fails to explain regards the magnetic data. Okay, then third point is not explaining the color inhibited by coordination compound, color of the compounds. So all coordination compounds are not colored. Some of them are having color and some of doesn't having a color. He is not explaining that why some coordination compound doesn't showing any colored nature or doesn't having any colored complex. So he fails to explain that why it is so, why it is giving a colored complexes and why not it's giving and it's not giving any color. So he fails to explain a color exhibited by coordination compound. Okay. Next one, he does not give a quantitative interpretation for thermodynamics or kinetic stability. Thermodynamics ಮತ್ತೆ kinetic stability ಅಂತ ಹೇಳಿದ್ರೆ, so there will be an activity, movement ಇರುತ್ತೆ, so there will be an energy. So suppose ಈಗ ಒಂದು coordination bond break ಆಯ್ತು ಅಂತ ಅಂದ್ರೆ, if suppose a coordination bond is going to get broken, so ಆ ತರ break ಆದಾಗ what is the energy liberated, what is the kinetic force of it, how much energy is required to make a coordination bond. So ಆ ಕಾನ್ಸೆಪ್ಟ್ ಗೆ ಸಂಬಂಧಪಟ್ಟಂತಹ ಥರ್ಮೋಡೈನಮಿಕ್ ಆರ್ ಕೈನೆಟಿಕ್ ಸ್ಟೆಬಿಲಿಟಿ ಬಗ್ಗೆ ಹೇಳಲ್ಲ. This fails to explain the thermodynamic or kinetic stability. And next point, it fails to explain the tetrahedral and square planar structure, why it having an coordination number 4 in though it's having a different structure. So is ಸ್ವಲ್ಪ ನಮಗೂ ಕನ್ಫ್ಯೂಷನ್ ಇದೆ ಅಲ್ವಾ. So in though square planar and tetrahedral and square planar having same coordination number 4. So ಎರಡರ coordination number 4 ಇದೆ, but structural wise and their hybridization wise they are going to different. So tetrahedral sp3 ಬರುತ್ತೆ, but in square planar dsp3. Why there will be a change in though it having same coordination number? Same coordination number ಇದ್ರೂ ಕೂಡ ಎರಡರ ಸ್ಟ್ರಕ್ಚರಲ್ ಮತ್ತೆ ಹೈಬ್ರಿಡೈಸೇಷನಲ್ ಫಾರ್ಮೆಟ್ ಯಾಕೆ ಚೇಂಜ್ ಇದೆ ಅನ್ನೋದನ್ನ ಅವನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಲ್ಲ. ಫಾರ್ ದಟ್ ಆಲ್ಸೋ ವಿ ಫೇಸ್ ಸಮ್ವಾಟ್ ಟ್ರಬಲಿಂಗ್ ಆರ್ ಕನ್ಫ್ಯೂಸಿಂಗ್ ಕೈಂಡ್ ಆಫ್ ಥಿಂಗ್ಸ್ ಇನ್ ಯೆಸ್ಟರ್ಡೇಸ್ ಕ್ಲಾಸ್. ಸೊ ಅವ್ನು ಯಾಕೆ ಆ ತರ ಆಗಿದೆ ಅಂತ ಅನ್ನೋದನ್ನ he is only not explaining that, and he is not explaining about the strong and weak ligands. ಸೊ ಸ್ಟ್ರಾಂಗ್ ಮತ್ತೆ ವೀಕ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಗಳ ಬಗ್ಗೆ ಅವನು ಏನನ್ನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಲ್ಲ. ಹಿ ಫೇಲ್ಸ್ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ರಿಗಾರ್ಡ್ಸ್ ದ ಸ್ಟ್ರಾಂಗ್ ಅಂಡ್ ವೀಕ್ ligands. Okay, is that fine? So these are 6 limitations you have for VBT theory. Then you have crystal field theory. So write down the limitations fast. Limitations ಬರ್ಕೊಳ್ಳಿ. Finished? Limitations of VBT theory. Okay, next you have crystal field theory. So what do you mean by crystal field theory? So crystal field theory ಏನು ಹೇಳುತ್ತೆ? So it is called as CFT. Crystal field theory. So what does it explain means there will be an electrostatic force of attraction. Electrostatic force of attraction between, there will be an, I'll repeat, there will be an electrostatic force of attraction between your central metal ion and ligand. So ಇವ್ರು ಏನ್ ಹೇಳ್ತಾರೆ, ಒಂದು ಫೋರ್ಸ್ ಇರುತ್ತೆ ಅದಿರುತ್ತೆ ಅಂತ. So he's clearly explained that there will be an electrostatic force of attraction between your central metal ion and with your ligand. ನಿಮ್ಮ ಲಿಗ್ಯಾಂಡಿಗೂ ಮತ್ತೆ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಅಯಾನಿಗೂ ಒಂದು ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇರುತ್ತೆ. That electrostatic force of attraction will hold your coordination, your metal with your ligand to make a coordination compound. ಆ ಒಂದು ಫೋರ್ಸು ನಿಮ್ಮ ಮೆಟಲ್ ಜೊತೆ ಲಿಗ್ಯಾಂಡ್ ಅಟ್ಯಾಚ್ ಆಗಿ ಇರುವ ರೀತಿ ಮಾಡುತ್ತೆ ಅನ್ನೋದನ್ನ ಹೇಳ್ತಾರೆ. So there will be an electrostatic force of attraction that holds the ligand towards the central metal ion to form a coordination complexes. Okay, ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Then he is explaining how the splitting of energy level, energy level ಗಳಿರುತ್ತಲ್ಲ. So it means to say from the higher energy level we are moving outside, like lower energy level in the higher energy level ಗೆ ಹೋಗ್ತೀವಿ. So he is saying that how the orbitals are going to split. How the splitting of an energy level. Fine. So he proposed some diagrams for the d orbitals. D orbital ಗೆ ಒಂದಷ್ಟು diagram ಗಳನ್ನ ಅವನು ಪ್ರಪೋಸ್ ಮಾಡ್ತಾನೆ. So he says this is y axis and this is x axis. This is called x minus and this one is y minus. So the charges are in the opposite direction. So this is the structure of dxy subshell. This is the structure of dxy subshell. Z, z minus. Here as usual y. You are also same opposite. You can ask me, ma'am, you are written this is y and this one is x. Because based on the subshell, Java subshell axis, that is called orientation. Based on the orientation of the axis, we are going to name whether it is x and y or y and z, like that. ಇಲ್ಲಿ ಯಾವ ಸಬ್ಶೆಲ್ ಅನ್ನ ನಾವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಿದೀವಿ ಅದರ ಓರಿಯೆಂಟೇಷನ್ ಮೇಲೆ ಇಲ್ಲಿ ಆಕ್ಸಿಸ್ ಗಳು ಚೇಂಜ್ ಆಗುತ್ತೆ. Okay, and as usual you know that D having 5 subshells. So this is called DXZ. DXZ. Okay. Can you able to see all three? So this is the 5 subshell you can see in d orbital. These are the orientation. So in the crystal field theory, he is going to explain the axis of orbital. Orbital ಗಳ axis ಅನ್ನ explain ಮಾಡ್ತಾರೆ. Okay. So this is called orientation of d orbital. This is called orientation, or you can say axis of d orbital, no problem. So these are the 5 subshell you can see in D 5 subshell ಗಳಿದು. ನಾನು ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುವಾಗ ಯೂಶುವಲಿ ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿರ್ತೀನಿ. dx square minus y square, dz square, dxy, yz and zy. No problem. There may be a arrangemental change ಆಗ್ಬೋದು, but these are the 5 subshell you can see in D. Okay. Okay, done. Next you have octahedral coordination entity. ಅಂದ್ರೆ octahedral ಅಲ್ಲಿ ಅಂದ್ರೆ all the 6 direction. So how you can say that the coordination structure ಅದು ಏನ್ ನೆಸಿಟಿ ಇಲ್ಲ, ಬಟ್ ಐ ರೈಟ್ ದಿ ಸ್ಟ್ರಕ್ಚರ್. ಒಂದ್ಸಲ ಸ್ಟ್ರಕ್ಚರ್ ಬರೀತೀನಿ, ನೋಡ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ. ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ splitting in octahedral coordination entities. You just join first 4 ಸ್ಟ್ರಕ್ಚರ್ ಹಾಕೊಳ್ಳಿ, then you can stretch in the ಅಂದ್ರೆ ಒಂದು ಬಾಕ್ಸ್ ಫಾರ್ಮೆಟ್ ಅಲ್ಲಿ ಬರೀರಿ. ಸೊ ಯು ಜಸ್ಟ್ ಲಿಂಕ್ ದ ಜಾಯಿಂಟ್ಸ್, ಎಲ್ಲಾ ಪಾಯಿಂಟ್ಸ್ ಇವನು ಲಿಂಕ್ ಮಾಡ್ತಾ ಹೋಗಿ ಅಷ್ಟೇ. So it's an y dash x z z dash y z. Okay. Just a second, I'm taking an attendance. Right on. Okay. Finish. Okay. Shall I move? Next you have excitations of orbital. So orbital ಅಲ್ಲಿ energy level ಹೇಗಿರುತ್ತೆ ಒಂದು ಆರ್ಬಿಟಲ್ಗೂ ಒಂದು ಆರ್ಬಿಟಲ್ಗೂ ಅಂತ. Let us see that in a diagrammatical representation. This is called free ion. ಫ್ರೀ ಅಯಾನ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್, so this is called stage 1. I'll explain, write it down fast. This is stage 2, ಇದು stage 3. ಸೊ ಇದು ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಕಾಣಿಸ್ತಾ ಇದೆಯಾ, ಬ್ಲರ್ ಆಗಿದೆಯಲ್ಲ,